Okay. So it's recording on this device now. So number one, the derivative of the function f is given by the following: f prime equals negative x over 3 plus cosine x squared. What value of x does f have a relative minimum on the interval from 0 to 3? So again, f prime. Now it's a little hard for me to scribe on my Mac here because I don't have a mouse or stylus. But f prime of x equals negative x over 3 plus cosine x squared. Okay, so I'm going to go to y equals. I'm going to clear what I have here already. And I'm simply going to type in my derivative, which is negative x over 3. So negative x over 3 plus cosine x squared. Now the question is asking you where you have a relative minimum. So first of all, we're going to go to mode, make sure I'm in degree mode. Sorry, radian mode, my bad. Go to zoom, and we'll do option 7Z trig. Okay. Obviously, we want to focus on 0 to 3, so let me go to window and switch that from 0 to 3. I don't care about the other stuff. Okay, so this is a derivative, okay? This is a derivative, not the original graph. So if I take a little spotlight here, okay, I don't know what is, this is so weird, okay. Hold on a sec. Let's do this really fast, okay. Hopefully it won't bug out anymore. Okay. There we go, all for a spotlight. So the derivative is positive and then becomes negative afterwards, right? That's a relative max right here. So here f prime is positive and here f prime is negative. So this right here is a relative max. Here, the derivative goes from negative to positive. So that's going to be relative min. A relative min happens right there. Remember, you're only going down then up to get a relative min. And then this is a relative max at this point. So I want that x coordinate. That's all I want. To do that, you go to your calculator, you go second trace, and you find the x-intercepts, which is zeros. So we'll do option 2. You can probably even trace close to it, but you know it's okay. We'll get spot on. Go a little to the left, go a little to the right, and you get 2.37. So the answer is C. Notice they put A as a trap, 1.094 and 2.608. That's where your relative maxes would be, but they want a relative min. So the answer is going to be C for number 1, just so you know. I'll record that as well. And you do have to do this in a TI-84 calculator. You cannot use Desmos for the paper version of the AP exam. Now, if you're doing a home on June 9th, digital, maybe because, I don't know, but there might be some feature when you log onto the college website that might turn off everything else in your browser. I don't know. I don't know. So just you know how to use a graphic calculator. I think that's going to be important. So and this is a 11 sample multiple choice. Okay, so that's C. Okay, now let's move on to number 2. Now for number 2, let me go ahead and clear this. Let me go ahead and clear my drawings. And we'll go back to the home screen. Okay. Number 2 says the second derivative g is given by g double prime of x equals 2 raised to negative x power. Then there's a plus cos x and a plus x. So you want to know when you're concave up. Now remember, we're concave up. Let's try that again. Concave up when f, or this case G double prime is positive, okay? When G double prime is positive. And you're already given the G double prime equation, so that's what we're gonna do. We're just gonna go straight to y equals, just punch it in very carefully. So you're gonna do 2 raised to negative x squared plus cos x plus x. Again, make sure you're in radian mode, which I am. And we're from -5 to 5, so it's always good to change that window as well, -5 to 5. And we'll just graph, see what happens, okay? So you want to be positive. Clearly we're positive wherever I see this x-intercept here, right? And beyond. So let's find that x-intercept. So you just go second trace, option 2, get close to it, go a little to the left, go a little to the right. We have -1.01 up to 5, because we're only going up to 5, right? So the answer is going to be B for this one. That's what we're concave about. Because remember, you're already given the G double prime graph. So you're just looking for the Y values. So, you know, that's what, and they give you average 3 minutes per question. So there's 15 questions that are like this with calculator allowed, and 45 minutes with regular time, by the way. So yeah, you know, that's how that looks. And then finally, let's do number 3. Then we're going to our breakout rooms after that. Okay, for number 3, they say the temperature in degrees Fahrenheit of a water in a pond is modeled by the following function, and they have h of t equals 55 minus 9 cos 2 pi over 365 times t plus 10, where t is number of days since January 1st, t equals 0. What is the instantaneous rate? So you don't want the derivative, right? Instantaneous rate derivative of the temperature of water at time t equals 90. So you don't want the derivative at t equals 90. So you could do this derivative by hand if you want. I would not recommend it. That would be very foolish. I would do this. I would go, you probably go to your home screen now. Now for free response questions, we do free response calculator tomorrow. We are gonna wanna store stuff under Y1 because we're gonna have to, you know, recall those equations over and over again for several parts. So here's just one question, it's a standalone question. So I can be in the home screen. So I'm gonna do alpha window. Remember, n derivatives right here, option 3. Do this with respect to x. And our function, be very carefully type that in. So it's going to be 55 minus 9. Again, that's why they give you extra time for these questions, because you got to be really careful with what you type in. Cosine, you don't have to put times, just put cosine. Now, if you want to put a fraction, you can. If it alpha y equals, call up option 1. I could do 2 pi, or you could do 2 pi slash, same thing. 2 pi over 365. 365. That pi looks really fancy there. Then parentheses x plus 10. Put another parentheses. And another parentheses. Yeah. And then type in 90. I think we're going to be A-OK. And make sure your mode is radian. Yes, it is. So you got 0.153. The answer is B. There you go. So again, just using the calculator, be careful. That's what you're doing. Okay. So good timing here, around it's 1:20-ish right now. So what we're going to do, I'm going to break you guys into two rooms. We'll just do one breakout room, and those are going to do conceptual questions, go with Ms. Bach, and then those that will do the more calculative questions will stay with me. So for Sydney's group, you guys are going to do. Just forgot that I'm actually on my Mac device, so my mouse won't work. So you guys are going to do. Let me do this as a text box. So for Sydney's group, you guys are going to do 4, 6, 8, 9. You guys need 4, 6, 8, 9. And then the rest are going to do, and let me just make sure I've got that correct. Yep. And I'm going to do 5, 7, 10, 11 with you guys. Okay, cool. Okay, so let's put just half you guys in. And I'm going to keep this recording going because that just makes sense. And let's see here, breakout rooms. Let's recreate them. Do one room, sign manually. Let's see, who do we got here today? We've got Albert, Billy, Granz, Eric Bowler, Katie S, Sarah L, and Will M. Okay, so we got, okay, so I'll put Albert, Billy, Granz, and Eric in the first group, and you'll be with Sydney as well. She's going to go over again 4, 6, 8, 9 with you guys. And I'll do 5, 7, 10, 11 with those who stay in the main room, which is Katie, Sarah, and Will. You guys will stay in the main room with me. And we'll do this for about 20 minutes or so. Actually, shoot. Sorry, I got to bring those guys back. I got to change the timing of it. Hold on a sec. Okay, sorry about that. I just have to change the timing. Let me recreate them. There we go. Just looks weird on a Mac. We'll do it for 20 minutes. Perfect. Actually, let's make it 15 minutes. Okay. Now you guys can go. Okay, so we got myself twice, and we got Katie, Will, and Sarah. Great. So here's what we're going to do. We're going to go over 5, 7, 10, 11 from the 11 sample problems green packet. Let me go ahead and share my screen again. Okay, we go in clear. So we're going to be working on number 5 right now. So number 5 says that the function is defined by h of x 1 over root x squared plus 5. If g is an antiderivative h and g of 2 equals 3, what is the value of g of 4? Now, Will, I know this will be kind of hard for you because you haven't seen this yet. Actually, you're going to start covering this when we start do this next week. So it might be kind of good that you're seeing this right now anyway. So what you want to realize is that this is going to be an integral from 2 to 4 of h of x dx. And because g is the antiderivative of h, because they said so, right? This is part of the fundamental theorem of calculus. It's going to be g of 4 minus g of 2. So you kind of want to know that conceptually first. This is straight up fundamental theorem of calculus. Now, g of 4 is what we want to find, right? So we got to find that. G of 2, we know straight up is 3. And here we're going to integrate from 2 to 4 of 1 over root x squared plus 5. Sorry, x to the 5th plus 1. Wow, can't believe I said that. X to the 5th plus 1 dx. So I'm going to let the calculator do its magic. So I'm going to do the integral, alpha window, option 4, from 2 to 4. And you could do the fraction part, alpha y equals option 1, 1 up top, down below root x squared plus 5, x squared plus, sorry, I don't know what's wrong, x to the 5th power plus 1, dx. You get that, and then you're going to add 3 to it to get g of 4. And that's what answers D, that one, number 5. The answer is D. Notice we put B as a trap if you just integrated, but you have to add 3 to it because that's g of 2. So that's number 5. Any questions about that one? Nope. Okay. So now I might have you guys try 7 on your own. 7, the derivative function f is given by the following. On what intervals is it decreasing? So what I want you to do, let me clear everything here. And clear this. Is go to y equals. I want you to type in that function. So e second ln sin x. Yikes, let's do that one time. Sin x, and the parentheses, minus cos x minus 1. Okay. And also make sure your mode is radian. Go to window, go from 0 to 9 for your window for x. And you can make that scale 1, I don't really care. And what you're going to do is you're going to graph it, and you want to see where f is decreasing. Now remember, this is f prime. You have an f prime graph. I'm not going to say much else. We'll give you guys about 30 seconds, a minute to figure out what you need to do. Where is f prime decreasing? And it's an f prime graph, mind you. If you have an answer, go speak your microphone or you can type in the chat. Actually, it did help that I made my interval from, I made my x scale 1. I think that helped a lot, actually. Okay, I think I've got the answer. Let me know when you got it. So where is f prime decreasing? Okay, anyone have an answer? Taking your time, okay. Okay. Hopefully you guys got A for 7. It's going to be A because it's an F prime graph, right? So you just want where the y values are negative. You just want negative y values for an F prime graph. That's definitely, you have negative y values here, and that's x equals 1. So from 0 to like 0.6, 0.7 something. And it's F prime is negative from 4 to about like 7. And remember, you're only looking at the y values in F prime graph. So the answer is just A. It's that simple. Just have to interpret it correctly, that's all. So we're not looking for slopes, negative slopes. That would be if I asked you where it's concave down. If I asked you that question, and you have F prime graph, then you gotta look at the slopes of the tangent lines, which would be probably from like 2 to about like 5 point something. So you gotta be careful about that, okay? So the answer is A. All right, so now let's take a look at 10, 11, and then we're gonna switch groups. This is good timing because we have about 6 more minutes left for this breakout session. For number 10, clear, okay. A rain barrel collects water off the roof of a house during 3 hours of heavy rainfall. The height of the water in the barrel increases at the following rates, where t is the time in hours since the rain began. At time t equals 1 hour, the height of the water is 0.75 foot. What is the height of the water in the barrel at time t equals 2 hours? So this is also another FTC style problem. What you have to do is you have to, or actually integrals net change, if you think of it like that. So what we're going to want to do is we're going to want to take the integral of r of t dt from 1 to 2. And that's going to equal the height of the water. So we could say h of t, we could call that height if you want. That's just height straight up. Okay. It's being a little frustrating. Okay. So let's try it one more time. H of t is height. And there'll be the antiderivative of r. Antiderivative of r. So then it's just going to be h of 2 minus h of 1 when you do the definite integral of r of t from 1 to 2. We already know h of 1 is, it's 0.75. You just got to do the integral of the rate. So this is where I could just go straight into the home screen. Alpha, window, option 4, 1 to 2 of 4x raised to the 3 power. Then e, so second ln, negative 1.5x dx. So 1.366, I'm adding 0.75 to that. So if I do plus 0.75, I get 2.111. So the answer is D. Okay, and then lastly, for number 11. A race car traveling a straight track at a velocity of 80 meters per second when the brakes are applied at t equals 0. From time t equals 0 to the moment the race car stops, the acceleration is given by the following function. During this time period, how far does a race car travel? Now remember, velocity is derivative of position, acceleration is derivative of velocity. If you're trying to go from acceleration all the way down to position, you're going to have to do the integral twice. So you're going to have to integrate A. So I could just do it on the I could do it on the calculator screen. So you would need to take the integral of your acceleration. Hold on a sec here. Actually, I'll need to work this out. So we're going to do the just simply the antiderivative of acceleration first, just as an indefinite integral. So you're taking the antiderivative of negative 6t squared minus t dt. If you do that correctly, you should get negative 6t cubed over 3 minus t squared over 2 plus c. And they do tell you that your initial velocity is 80. So v of 0 has to equal 80. You know this. So 80, if you plug in 0 for t, c is just going to be 80. So now I actually have the c value. It's just going to be 80. Then what you need to do is do this again. So time to the time the race car stops. So when does a race car stop? It stops when v is 0, right? So you have negative 2t cubed minus 0.5 t squared plus a. So we have to see where the race car stops. Obviously in 0, you're at 80. So actually, I'm going to have to graph this. So I'm going to do negative 2x cubed. This is a little more involved. Minus 0.5 x squared, 0.5 minus 0.5 x squared plus 80. Okay. Zoom. Just graph the standard window. So it crosses, it stops at probably 3 point something. Actually, let me adjust the window. Keep that open. Obviously, it will do from 0 to 10. Let me increase that to like maybe hundreds. Okay. So I gotta see where that happens. So I gotta find the zeros. Left, right. So 3.333. Then what I need to do is I need to do the integral of that from 0 to that number. And that will tell me how far I've traveled. Because that's, when you do the integral of your velocity, that's going to be your displacement. And the whole velocity is positive, so you don't have to do an absolute value, just so you know. But you should technically do that. So now, remember, I already have it stored under y1. So if I just do alpha window, option 4, from 0, and I can just type in x, because I already have it stored as 3 point whatever, and go alpha trace y1, because that's my velocity function, dx, I should get the answer at that point. 198.766, cool, speed. So that's a little more involved, but again, you have to use a calculator to kind of get that answer too. And so it involves a little bit of FTC as well, and like, solving differential equations in a way. Okay, cool. So the other group is back, which is good timing. So I'm going to put Katie, Sarah, and Will in Sydney's group. You guys are going to do conceptual questions. Those who are back are going to stay with me. We're going to do some of these calculator questions here. And the last one's a fun one, as I've just discovered. So stop sharing. I'm actually going to stop recording because